Today we are going to learn about close packing in 3 dimension. 3 dimension means length, breadth, height. In the last videos we have learned how the atoms are placed in 1 dimension and 2 dimension. In 2 dimension we have seen two types of packing. One is square close packing, another one is hexagonal close packing. From the square close packing, we have seen each atom is surrounded by 4 atoms. In hexagonal close packing, we have seen that 6 atoms are surrounded. Each atom is surrounded by 6 atoms. Now, today we are going to learn about close packing in 3 dimension. 3 dimension means length, breadth and height. There are two types of 3 dimensional packing. First one, 3 dimensional packing from that is square close packed layers. From square close packed layers. Here atoms arranged like this. While placing the second layer above the first, the same rule is followed. The second layer is placed over the first layer such that the spheres of the upper layer exactly on the first layer. So it is aligned both horizontally as well as vertically. Similarly, we can place one more layer. So like this structure we are getting. Length, breadth and height. This is A type lattice. This represents simple cubic lattice. Already we have learned simple cubic means 8 atoms in the corners. It is a primitive cubic unit cell. Only polonium can crystallize like this structure. Only polonium. So this is one type of packing, 3-dimensional packing. Another type from hexagonal close packed layers. From hexagonal close packed layers. Here there are two type of arrangement. AB type. The other one is ABC type. First we can see AB type. AB type. In the first layer, second row of atoms kept in the depression of the first row. So here two types of voids are formed. Void A in first row and void B in second row. Void A in first row and void B in second row. Triangular void. In void A, the apex of the triangle pointing upwards like this. Void A. In void B, apex of the triangle pointing downwards. This is the first layer, layer A. Now, the second layer B can be placed any one of the void, either void A or in the void B. But it cannot be placed simultaneously on both the voids. Either on the void A or on the void B is kept the second layer. So now I am placing the second layer on void B. Void A. Void B is not occupied. Void A. This is layer B. It is kept on the void A. So, the void A in which apex of the triangle pointing upward, since void the layer B, since it is placed on the layer A, the triangular void led to different arrangement. So therefore a tetrahedral void is formed. Tetrahedral void, that is void between four atoms. Void between four atoms. That is three atoms in the first layer and one atom kept above. This is a tetrahedral void. Three atoms in one layer and fourth atom in the second layer. Coordination number is 4. So, the void, one atom above the plane of the void, three atoms kept below the plane of the void. On joining, we are getting a shape of a tetrahedron. So this is called as a tetrahedral void. Tetrahedral shape. So it is called as a tetrahedral void. At other places, apart from the void A, at other places, the triangular void in the second layer are above the triangular void in the first layer. So one of them has the apex of the triangle pointing upwards and other pointing downwards. Such voids are surrounded by 6 spheres. 6 spheres. So, octahedral voids. 3 atoms in layer A and 3 atoms in layer B. Three atoms in layer A and 3 atoms in layer B. This is the octahedral void. Coordination number is 6. That is the shape. Like this octahedral shape. So in second placing the layer B, we are getting two types of voids, tetrahedral voids and octahedral voids. Tetrahedral void coordination number is 4, octahedral void coordination number is 6. By placing the third layer of atoms, two types of arrangement. You have to place the third layer. So in third layer, there are two type of arrangement. Third layer can be placed parallel to void B or parallel to the layer A itself. Parallel to the void B or parallel to the void A itself. So, placing the third layer on void B. So you have to draw the third layer on void B. So this is layer C. Layer C. So regarding the shape, coordination number is 12. Regarding the shape, one atom in layer A, one atom in layer A, layer B, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Then this is layer B, then layer C, 1, 2, 3, 4, 5, 6. This is layer C. 6 atoms in layer B, 6 atoms in layer C, 1 atom in the layer A. It is a cube with atoms in corners and in face centers. So it is also called as FCC, face-centered cubic lattice or cubic close packed structures. So here 74% occupied by atoms, remaining 26% are voids. Metals such as copper, silver can obey this type of arrangement. This is one type of arrangement. Second type of arrangement, the third layer exactly in A. So this is layer A, layer A, layer B in void A, this is A, this is B, then layer A exactly on layer A, layer A. So this is called as AB type. Coordination number is 12. So this structure is hexagonal close packed structure, HCP. This sort of arrangement is found in many metals like magnesium and zinc. So regarding the structure here, shape of a hexagon. Layer A, this is layer B, and this is layer A. This is shape of a hexagon. So this is called as hexagonal cubic close packed structures. So here this FCC equal to CCP, cubically close packed structures, is equal to HCP.